Hi guys, happy Monday. Here we are with 06.01 representing data. So we're starting to go into our statistics unit. Here we are on page 1. It says representing data. Statistics draw inferences or conclusions about something. So it talks about how companies, they use a lot of statistics to compare, to contrast, to really sell things to people. They use these statistics, for example, in the Super Bowl with airtime, very rewarding, meaning money, essentially. So some interesting statistics, 73.6% of American commuters or consumers, watch the Super Bowl. In 2012, they spent an average of $63.87 per person, and the related purchases amounted to over $11 billion. So in using statistics and analyzing, you can really find a way to market and truly produce the best thing, the most visually appealing thing. So when we talk about what is data, data are collected information about a given topic. Data or data, doesn't matter how you say it. Collecting data can help someone learn more about a particular topic and make conclusions. So it leads you to a specific answer at the end. So there has to be some sort of a question first. The study of data is known as statistics. So there is a statistical process, kind of like a four-step process, where first you have to form a question. So this question has to be answered by the data. Step 2 is to design and implement a plan that collects appropriate data. So you have to go through the process of collecting these responses. Step 3 is to analyze the data using graphical or numerical methods, so kind of like charts or graphs, which we're going to talk about later. And then step 4 is to interpret the data in relation to the original question. So you can't just have all the data and not do anything with it. You actually have to present it and show it, interpret it in a way that's going to make sense. So the statistical process is a way to collect, organize, understand, and represent data. This might kind of look familiar to the scientific method that you learn a lot about in science, where you have to follow the specific process when you're talking about data. And here you can see that they have a chart of a specific type of data or certain thing that they collected, data they collected in a very visually appealing graph. This is a pie chart, pie graph. We have 60% electronics, 30% for clothing, 7% food, and then 3% for school supplies. Something that you will notice that all of our data pieces added together, so 60% plus the 30% plus the 7% plus the 3% is going to add up to 100% total, which we know from all of our work with percents in the past. So step 1, forming and designing a plan. The first 2 steps in the statistical process are to formulate, design, and implement a plan to follow. The steps are foundational to the process, so it can be replicated if needed by the other mathematicians or those wanting to duplicate or verify the results. So a lot of times there's people who do the same studies or data collecting over and over and over again, and they try to make it better each time that they do it. So then step 1 is to form a question that can be answered by data. So statistical questions specify populations and measurements of interest, so whatever you're interested in. The question should also anticipate answers based on data that vary, but anticipate fixed answers. No randomness is involved. The answers to statistical questions will address the variation in data, use probability statements, and apply only to the population specified. So a couple different questions that you want to keep in mind, and we'll talk about those in a second, are statistical and non-statistical questions, so different types of questions that give you different types of answers depending on what you're asking for. And there's 2 different types of data, categorical and then quantitative data. So whenever I see these 2 words, categorical, I think of categories. So that's where you place your answers or your data into categories. And then quantitative data is like quantity. So that's going to be your numbers. Your data can be arranged in numbers or groups of numbers. So here the lesson gives a really good breakdown on the difference between non-statistical questions and then an actual statistical question. So comparison, and then it gives you the reason. So for example, non-statistical would be, does the pesticide Raid harm butterflies? How has the Common Core state standards changed our school? How tall is Sheila? How many words are there in this sentence? And then to compare with that or contrast the statistical question, for the first one it says, what is the mortality rate in icolas erythrin 1 hour after treatment with RAID. Sorry, I totally botched that, but you'll notice how specific that question is versus the previous one on the left. It says, since the implementation of the Common Core State Standards, what is the change in the mean? So there's a statistics related word. How tall are the students in my Algebra 1 class? So it's not just the one person, Sheila, but it's more people included in the data set. And then how many words are there in each sentence of Chapter 12 of the Scarlet Letter? So you'll notice in the reasoning it says a lot of the first question being too broad. You can't really collect data where you don't really know exactly what you're collecting. So you have to be precise and you have to be measurable in your data. And then for the last two questions, it highlights the fact that the original questions don't allow for enough data. So how tall is Sheila? That's just how tall one person is. So it's hard to really collect information on just that one thing when you're just going to have one answer. And then we call that kind of like a data pool or a data set. So you want to have a good amount of information or a good amount of numbers in your data. So expanding a little more on the two different types of data, we have our categorical data. So like I was saying earlier, it really separates your data into different categories. That's how I think of it. So a survey was conducted to find out the ninth graders' favorite sport. We have football, basketball, baseball, hockey, or soccer. Data could fit into the following categories, depending on what they answer. The data would be represented in the 5 categories. So we have our chart here. We have 25 for football, 22 basketball, so on and so forth. Each category contains a count that represents a specific number of students who responded with that sport. So it is in categories. Now, our quantitative data is all about the numerical side of it, where it talks about counts or measurements. So you can have your data either organized into specific numbers or integers like 1, 2, 3, 4, depending on what your data is, or it could be in different ranges or groups. So in the example we have here, it's talking about percentages of free throws, and we have 45 to 55%, 56 to 65, and so on with the different ranges of the percentages. So it's kind of a category, but it's numbers. So we call it our quantitative data. It's not like I'm organizing it into awesome, good, bad, terrible. Those would be categories. This actually has numbers that's attached to it. So now that we talked about categorical and quantitative, we're going to take a look at some number sets to determine if they are quantitative or categorical in nature. So in the lesson, at the bottom, you'd click on number sets. Here's what we have. It says the breed of dogs that a person has. Well, you're classifying them into certain breeds. There's no numbers really going on here, so categorical. The average number of dogs. Average number. So we're talking about numbers here. That's going to be quantitative. Time it takes for a person to commute to work. We're talking about time. Time is numbers, so definitely quantitative. And then the model of a person's car, that will be categorical as well. All right, so after step one of after you've figured out your question and what kind of data you're going to calculate, you have to design and implement a plan that collects the appropriate data. So in the process, the plan must be designed. You have to figure out how you're going to graph it, what exactly you're going to collect, and that it's appropriate to the question and the outcome that you want. So there's two different types of ways that you can collect data or design this plan. You can either use experiments, where the researcher deliberately imposes some treatment on individuals and observes their responses. And then we have observational studies where the researcher observes individuals but does not attempt to influence the responses. So for example, if you just put out a survey, you're not really influencing them to answer one way or another, you're just trying to collect responses, whereas if you're doing an experiment, you may be trying to persuade someone one way or the other depending on how you're asking your questions. And then it says it is important to remember that if an experiment or study is only to be administered to a sample of the population, those subjects should be chosen at random. You don't want to say, what's your favorite sport? Let's survey all of the hockey players, because that's going to be pretty biased. Most likely they're going to pick hockey. That's why in the previous study, they picked the ninth graders, because you have a bunch of different type of people in that group. So here we're trying to categorize into categorical or quantitative data. We have a car class, which is compact, midsize, full-size, luxury, truck/SUV. And then the type of people that have those cars, that's different categories of cars. So that's going to be categorical data. Question 2 says height in inches of people. We have ranges from 70 to 72, 73 to 74, and so on. That will be quantitative data because you have number ranges. We are in the number, it's not a title category. And then question 3, we have types of pets, cat, dog, hamster, etc. That's definitely going to be categorical. We're putting these students and how many pets they have or what kind into categories. There's no number data attached to our different buckets. And page 3, the remaining 2 steps of the statistical process are used to summarize the data and make sense of the findings. If the data isn't analyzed, interpreted, or presented well, the information can be confusing, misleading, or even useless for making informed decisions. So we have to keep in mind that representing data is all about telling a story, and pictures or graphical representations do a remarkable job of getting the point across. So if you want someone to understand exactly what you're trying to say, you got to make sure you represent your data in a good way. One of those ways is a dot plot. So the dot plot is very much like a number line, and there's a couple of steps to creating a dot plot. So let's say, for example, we're just going to create a random dot plot. So we're going to make a horizontal line with an appropriate range. So I'm just going to make up numbers. I'm going to start at 0, and then I'm going to go to positive 20, positive 40, and then 60, and then I'm going to do the opposite on the other side. So negative 20, negative 40. I don't think anything is going to get to negative 60 because I want to talk about the temperature in, let's say, New York. On average, let's say per week, I don't know, per a day. And I'm just making this up as I kind of go along. So then what I want to do is, depending on how many times we hit this temperature, I'm going to put a dot above the temperature every time that happens. So let's say on Monday and Tuesday you get negative 20 degrees, I'm going to do 2 dots. Then you have a 0 degree one day, you have 3 days of 40 degrees, 1 day of 60 degrees. So the frequency at which these numbers happen, or that you have this data, you put dots and then you want to label it. So we have Fahrenheit in degrees and then temperature in New York. All right, so example number 1. Wesley's class is doing an activity about data collection. The students are collecting data to answer the question, on average, how many dandelions can be found inside the area of one hula hoop? All the groups threw their hula hoops, and the data sets are as shown there in the list. And I can't select the audio because I'm talking over it, but here's the example. And then what they went ahead and did is they took Wesley's class data and they arranged it. And something that you'll notice is I always suggest that you look for the lowest and then the highest. You want to know kind of what your range is. So the lowest is 8, the highest is 13. If you look at the dot plot below, you have 8 as your lowest number, 13 as your highest number. You really only need enough numbers to account for the least to the greatest and then everything in between. And then you'll notice that they put a dot above each number for the averages that Wesley's class found. So 8 had 1, 9 had 2, so on and so forth. They did label it class activity. They have the x-axis labeled number of dandelions, and this is how you represent data very visually, and it's clear to see that 10 is the largest average that they had. Now for our next example here, for the dot plot, you'll see that in the table where it says color, tally, frequency, and then the dot plot, they show the same information, but it's actually a lot easier to see in the dot plot which one is the highest. So I could tell maybe I have to count between blue and purple, but I can very quickly see that purple has the highest amount. So especially if this table is larger and there's a lot more numbers, it's very easy to see in a dot plot which one's going to be the highest. I just look for the largest frequency, which would be purple. All right, so example number 3, we have in anatomy, Percy learned that the average resting heart rate is between 60 and 100 beats per minute. He decides to record the average heart rate of people over 5 minutes while waiting in line at the pharmacy. His results are as follows. So we have a long list of numbers here. What can Percy conclude about the people waiting in line at the pharmacy? So in my opinion, it's kind of hard to come to any kind of conclusion when the numbers are all over the place like this. So something that you might want to do is order your numbers from least to greatest. Just by looking through it, I see that 62 is my lowest, and I only have one of them, so I'm just going to cross that out because I already wrote down 62 below. 63 I don't have, 64 I don't have, no 65. As I keep looking, it looks like my next one is 68. And I have 1, 2, 3. Looks like 3 of those. So what I'm going to do is I'm going to write 68 and then just write in parentheses 3 so I know that I have 3 of them. I don't have to write it 3 times. And then it looks like I have 169 there. And then I have 70. How many times? Let's see. I have 1, 2 right there. So I'm going to write 70 and then in parentheses 2. And then I'm going to keep doing this same thing until I have all of my numbers ordered from least to greatest and the frequency at which they occur. So as I get closer to the end, you'll see that I've been doing this for a little bit. I had 72 3 times, I had 75 twice, 76 just once, so I just wrote 76, 78 twice, 80 happened 3 times, and then 89 happened twice. Now that I have my data in order, I'm going to go ahead and create my dot plot. And all I need is the numbers where I start and the number where I end and everything in between. So I'm going to start at 62 on the left, and then I'm going to end with 89 all the way to the right. And I got to make sure I space out all of my different numbers in between. And there's no real science to making this exact. You just kind of got to do as best as you can. Sometimes it might come out sloppy, but it's okay. And I'm just going to space out my numbers and count out certain markers here. So I have 70, 80, and then I'm going to go in and count out also by 5. So 65, 75, and 85. I'm going to write down approximately where those are as well. Now, after I'm done doing that and I have kind of my milestones here, I don't want to write out every single number because that's going to be extremely cluttered. But now what I'm going to do is I'm going to go out and start putting my dots. So on 62 I have 1, on 68 I have 3, on 69 I have 1, on 70 I have 2, and hopefully you get the point. I'm going to keep going. So on 75, or sorry, on 72 I have 3, on 75 I have 2, on 76 I have 1, on 78 I have 2, on 80 I have 3, and then on 89 I have 2. Now, Percy is asking what can he conclude about the people waiting in line? Well, to me it looks like everyone is at least average, right? So between 60 and 100 beats per minute. And I'm going to notice that we have 2 people at 89 beats per minute and 1 at 62. That's kind of further away from the bulk of the data in the middle, I guess you could say. So those that are kind of further away from the general bulk, which is around from 68 to 80, and those that I circled in yellow are going to be kind of further away from our general central data. So as you can see here in the actual answer, a lot prettier than what I did, but essentially the same point where we have our dots with a certain frequency of the beats per minute that happened. So it's the 20 people around 60 to 100, which is normal. And then we had 1 person at 62 and 2 people at 89 that were kind of out of the normal. And we kind of call those outliers because they're not with the majority part of our data, we could say. And here is our try it last thing on this page. So we have the following table displays how many computers are owned. So computers 1, 2, 3, 4. These are not categories, these are numbers. So this is going to be quantitative data. And we have 3 families, 1 family, 5 family, 2 families. So I'm going to do a quick dot plot. For 1 computer, I'm going to put 3 dots because that's the data that I have. 2 computers is 1 dot, 3 computers is 5 dots, 4 computers is 2 dots. Obviously, if you do it by hand, it's not going to be super pretty. I'm just doing this really quick. And then we do want to make sure we title our dot plot as well. So I know my x-axis is going to be the number of computers. Actually, I kind of did that backwards. It's going to be the number of computers, and then I would probably title this number of computers per family. And then here we have question 2, which has a dot plot for us. It says Maddie surveyed people at the mall to find out their color preference. She gave people the choice of those, as you can see. Use the given dot plot. How many total people were surveyed about color preference? So the dots represent a person because it's about frequency. So I'm just going to count them up. Red goes up to 8, orange goes up to 4, yellow is up to 6, green is also 4, purple, if I count that all the way up, it looks like it's going to be 15, and then blue goes up to 4 as well. So if I add all those up together, I'm going to have a total of 41 people who were surveyed because I have 41 answers. And then it asks me how many total like red and blue. So I'm just going to take red plus blue because it's and. I want both of them. 8 plus 4 is going to get me an answer of 12 for that one, of how many total like red and blue. Now, not only can we use dot plots to represent our data, but we can also use bar graphs and histograms. So bar graphs and histograms look very similar, but they're used for different types of data. A bar graph is typically to represent categorical data, where histograms are used to represent quantitative data. So we have to be able to recognize which is which based on the type of data that we have. So for our first part here, it says bar graphs. A survey of 195 people showed their favorite fruit. Here's the table here. So we have fruit, orange, apple, blueberry, banana, strawberry. That's definitely in categories. Since this is categorical data, we are going to use a bar graph, and here's what the lesson shows us. So you'll see with the bar graph across the bottom, across the x-axis, we have the different categories as listed, and then across the y-axis going up, we have the different frequencies of the data that's occurring in intervals. So it went 10, 20, 30, 40, 50. So it says the categories are labeled across the x-axis, and the frequency, so like I just said, the number of times at which it occurs, the frequency is measured vertically. And then on the bar graph, everything is noted, everything is labeled. Both would adequately represent the data, but this graph would be much more concise and easier to read if it is a bar graph, because if I use a dot plot, for example, that would be a lot of dots to put on your graph. So, bar graph example, it says a survey asked people to pick their biggest fear from a list of spiders, snakes, public speaking, flying, and the dark. 18 people responded that spiders were their biggest fear, 12 were scared of snakes, 25 of public speaking, 9 of flying, and 14 were afraid of the dark. Again, this is categorical data because their fears are placed into categories. So I would be using a bar graph for this one. That would be most appropriate. I could use a dot plot, but this is going to be a lot of dots. I have to do 18 dots, 12 dots, 25 dots. So I'm going to do a bar graph since it's categorical data. So across the bottom, the x-axis, I'm going to go ahead and do my categories, just shortened. So spiders, SP, snakes, SN. Then we have public speaking. Then we have flying, and then D for dark. And then up vertically, the y-axis, I need to figure out how I'm going to represent my frequencies. So my lowest, it looks like, is 9, my fear of flying. My highest is 25, which is public speaking. So I know I need to have the range of at least 9 to 25. So I think I'm just going to go by fives. So 5, 10, 15, 20, 25, and then up to 30 to make sure I have everything. So then what I'm going to do is I'm going to draw essentially a bar going from the bottom 0 up until the frequency at which it occurs. So for spider, I'm going to go up to about 20, and this isn't going to be perfect because I'm doing it freehand. I don't really actually have graph paper. So it would be a lot better if it was on graph paper. But then for snakes, I'm going up until 12 and kind of making my bar here. For public speaking, I want to go ahead and go all the way up to about 25. And I'm hoping at this point you see the point of what I'm doing. And then for flying, I'm going to go up to 9. And for afraid of the dark, I'm going to go up to about 14. Now, the thing with my freehand bar graph is that the graphs aren't right next to each other. Typically, the ones that you see that were drawn on the computer are going to be one right next to the other. It doesn't have to be like that as long as you're representing the data. And with the bar graph, just like with the dot plot, you can see that for sure flying is going to be the lowest, and then public speaking is going to be the highest amount. Here's the graph that they put together with technology, definitely a lot better than mine. As you'll see, the bars aren't right next to each other, which is fine if you do or if you don't. It just depends on the person who creates the graph, but it's pretty much exactly like what we have. And you can see very clearly that the lowest is going to be flying for the fear, and then the highest is going to be public speaking. All right, so switching gears, if you have data that is quantitative, so if you have numbers, then we want to use a histogram. So a histogram has certain numbers here, so we're going from 1 all the way to 35, and the first thing we need to do is determine the bins or ranges or batches or bunches, however you want to say it. The thing for histograms is that they have to be completely equal, and you'll see what I mean in just a moment. So to draw and label the horizontal axis. So we created the bins with grouping like numbers together from 1 through 4, 9, 10, 12 was by itself, so on. And the reason why we did that is that so we could have equal buckets. They call it bins. I kind of like to say buckets, but 1 through 5, 6 through 10, 11 to 15, they all have different buckets of 5 numbers. So 1 through 5 is 5 numbers, 6 through 10 is 5 numbers, and so on. So my histogram has data arranged into these equal buckets. For the y-axis, I want to draw the frequency at which these occur and then draw it up. So in the bucket or the bin 1 through 5, there's 3. We have 1, 4, 4. So I'm going to draw my bar. It's kind of like a bar graph, but not really. It's called a histogram. I'm going from my bucket 1 through 5 up until 3. In the bucket 6 through 10, I have a frequency of 2. In the bucket 11 to 15, I have the frequency of 1. In the bucket 16 to 20, I have a frequency of 4, according to my data. In the buckets 21 to 25 and 26 to 30, I have no data, so I'm not going to draw anything. And then in the last bucket from 31 to 35, I have 5 data points, so I'm going to draw my histogram all the way up to 5. Now on the last page, I kind of already colored that in, but they have it here more professionally done. They labeled everything as well, so they titled it weekly reading. We have our frequency on the y-axis and then the number of pages read on the x-axis, and this is how we represent visually our data when it's quantitative. We have our different buckets or bins, and you can see very clearly that our lowest number of pages is in the bucket 11 to 5, and then the highest is in the bucket 31 to 35. So here's our first example with histograms. It says a survey of 20 people was conducted with the following table showing height. So 60 to 63 is 4, 63 to 66 is 6, and so on. A histogram shows numbers in ranges, sometimes called intervals or bins, again I like to call it buckets, along the x-axis. This makes histograms appropriate to display numerical data such as weight, height, or time. Note the first 2 ranges in the table, 60 to 63 and 63 to 66. Which interval would a person fall if he or she was 63.5 inches tall? Well, that's definitely going to be the second group because 63, starting at 63, 63.5 is larger than 63. So it's going to fit in that 63 to 66 bucket. It also explains that I would use a histogram because this is quantitative data. Using this, I can have decimals, and it's definitely not categories, so this is going to be quantitative data. Okay, so here's the actual histogram based on the data. So we have our little buckets or bins or ranges across the bottom, whatever you want to call it. You'll see that the first one goes from 60 to 63, then 63 to 66, 66 to 69, and then 69 to 72, just like what was in the data. And the frequency is over up at the y-axis. So essentially our histograms are extremely similar to our bar graphs. They look the same, except we're using it for our buckets at the bottom and not categories. So representing data, our histogram example number 2, it says a researcher wanted to find out how SAT scores were distributed amongst high school students in a town. We have our results displayed here. Determine what type of data was collected. Was it categorical or quantitative? Would a bar graph or histogram be more appropriate? Well, my scores are numbers. They are in ranges. I can also think about it as being in the buckets or the bins. This is definitely going to be a quantitative graph. I am going to use a histogram for this data. Here's what the histogram looks like, just like we would expect it to. We have the buckets across the bottom, like it tells us, and then it goes up the y-axis to the frequency that it was. So the largest amount was there in the middle between 1401 and a 1700 score, all the way up to over 60. Now we have a couple of questions, our try it questions. Question 1 says, which of the following can be said for certain from the histogram? It says, more people surveyed are between 66 and 69 inches tall than any other range. Well, that's definitely true. If we go through the other ones, it's going to be obvious that the other ones are not true. The only one that's true is the first statement. And question number 2 says, using only the bar graph provided, estimate how many total people were surveyed regarding their fears. I'm going to assume that I have never seen this before, even though we just talked about it on one of the last examples, but spiders, looks like it's about 18 or 19. Snakes is 11 or 12. Public speaking looks like it's up at 25. Flying is right under 10, so I'm going to say 9. And then the dark looks like to me 13. So if I had not seen this before, we can use our bar graph to kind of estimate. That's why it says estimate. We're kind of guessing because it's not precise exactly. Make a pretty good analysis of the data based on what it looks like. So what's the difference in the number of people that are afraid of spiders opposed to snakes? Well, actually the total is going to be 77 if I add them all up, and then the difference is going to be 18 to 12, which is going to be 6. All right, so page 5, we have some activities. It says recent midterm grades in a math class, categorical or quantitative. Categorical for sure, even though we sometimes think of grades as being represented by numbers, the A, B, C, D are categories. Weight range of students, numbers, definitely quantitative. We have our buckets there that we see if we were to graph that. Question number 3, survey of favorite genres of books, definitely categorical because it's different categories for sure. Activity number 2, let's see, we're talking about swimmers at the Olympics. They have their different times. It says, what type of graph would work better? Well, it's numbers. This is going to be quantitative data, so I'm going to go with a histogram, definitely. And we go from a minute 5 seconds and 43 milliseconds up to a minute 6 seconds and 95. So it looks like each bucket, it tells us, is going to be about 50 seconds, or not 50 seconds actually, 50 milliseconds. And so we're looking for the appropriate intervals. Well, it has to be buckets. So I know for sure it has to be a range for the x-axis. It definitely can't be the last two because those ranges aren't correct. We would be missing out completely on this first one if I start at 0.50. So I'm going to look at between the first two. And based on what they were telling us, we had one person in the first bucket, one person in the second, one person in the third, and 2 people in the fourth bucket. So it's definitely going to be answer A for that. And then back up to the top, looking at activity number 3. We have the following: cherry tree heights in feet around the town. We're talking about numbers here. Height's definitely going to be a histogram because it's quantitative data. It's going to be ranges, and it actually tells us that it's going to be broken up into intervals of 5 feet per bin. So I'm going to look and see my lowest height, it looks like to be a 61, and then my highest one is 90. So if they want 5 feet per bin, I'm going to guess that they're going to want to go from 60 to 65, 66 to 70, 71 to 75, 76 to 80, so on and so forth for this histogram. I'm not going to draw it out. We're just going to see what they say here for question number 2. For the x and the y-axis, exactly like what I was saying, but they're actually going from 65 to 70, then 70 to 75, because you can actually have decimals for this if you wanted to. And then for how many are in each bucket, they actually counted it out. They had 2 in the range from 60 to 65, 3 from 65 to 70, and then 7, 12, and so on. Activity number 4, the following data shows the number of songs downloaded. Create the plot. Create a plot. Sorry, I can't read. To best represent the data. So we have, it looks like my lowest number is actually 0. Okay. My highest number looks like it's about 32. They went ahead and created a histogram here with different buckets or bins. So 0 to 10, 11 to 20, and they have the different numbers here. And this is the histogram that they went ahead and created. And I think that's going to wrap up our video for 06.01. The next slide should be our yellow review/overview page for everything that we talked about in this lesson, talking about data and our statistical process that we follow. We cover dot plots, we did bar graphs, we did histograms, all of that. So as always, let me know if you guys need any help. Feel free to contact me anytime, and I will see you in the next video for 06.02.